All right, so today we're going to talk about polynomial division. First, we're going to review how to do polynomial division and how to do synthetic division. So you've done this maybe before, but it probably has been a while. So as a warm-up or a practice, divide this by hand using long division, and then write your answer as number plus a fraction. All right, so how would we do this? So you put 7 on the outside, make your long division with 195. It's a little long here. So we're trying to figure out how many times does 7 go into our number, our first one. So you would first see, can 7 go into 1? Nope. So now we want to check how many times does 7 go into 19. So 7 times 2 is 14, and then 7 times 3 is 21. So this would be 2 up here. Then you want to do 2 times 17 here, and you'll get 14. And then subtract those two numbers. You'll get 5, drop this down. So now we have 55. So now figure out how many times does 7 go into 55. The answer here is 7, because 7 times 7 is 49, but then 7 times 8 is 56. So you can't go in 8 times. Same thing here, subtract. We'll get 6, and then we have nothing else here. So you could add a decimal and a 0 and then get your decimal answers that way, but we're just going to write this as 6 plus 6 over 7. So you have 6/7 left over. This is your remainder. So that's your quick review of long division. And now we're going to do it with a polynomial. So same exact concept, same idea, it's just a little bit more complicated because you have a bunch of stuff going on. So if we have this question, we can write it like this. You take the bottom on the outside, the top on the inside. So now we're trying to figure out this first term, 2x, how can I make that look like 6x squared? What do you need to multiply by? So to get the 6, we need to multiply by 3. And to get the x squared, you need to multiply by x. So we need to multiply by 3x. At this point, you need to distribute this to both terms. So we'll get 6x squared plus 15x. Now a note here, what we did at the beginning, we subtracted. So you need to subtract here, but we're subtracting everything. So it's going to be a negative 6x squared and a negative 15x. It's super easy, and people make this mistake a lot, to not subtract this right here. They end up adding that one. That doesn't work. You need to subtract from both. So these are going to cancel, which is what you want. And then we have negative 7x minus 15x. So we'll get negative 22x here. Now drop down your negative 52 and repeat the process. So 2x times what would give you negative 22x? Negative 11. So multiply through again to both of them. You'll get negative 22x, which is what we wanted to cancel it out, minus 55. And again, you're subtracting both, so these will cancel. And then you have negative 52 minus a negative 55, so you'll end up getting a positive 3. At this point, you can check back. Is there any way to get a 2x to look like a 3? Not unless you divide by an x. You can't. Once you're like a degree less than whatever you started with, your polynomial, then you can't go any farther. So this is the remainder. And we can add that on like we did before as 3 over whatever you divided by. So this would be your answer. You have a polynomial plus a fraction. Okay, we'll do another one here. So a little bit longer. We have 2x squared minus x plus 2. We want to divide 8x to the fourth plus 6x squared minus 3x plus 1 by this. If you look here at what I have written, there's a 0x cubed right here. That's kind of just a placeholder, because when I multiply this out, I'm going to end up like skipping over some stuff, or I need to subtract from an x to the third, but there's no x to the third up here. So you don't have to include that in your under the square root or the division symbol, but it's very helpful to keep track of what everything is in your columns. So again, we want these to look the same. So how can I multiply 2x squared to look like 8x to the fourth? You're going to want to multiply by 4x squared. And then this needs to distribute to all three of these. So you'll get 8x to the fourth minus 4x cubed plus 8x squared. So this is where it's helpful to have this, because now I have somewhere to subtract that negative 4 to the x cubed from. If you didn't have that placeholder there, then you wouldn't have anywhere to put that number, and it kind of can get messy. Again, you're subtracting everything, so those are going to cancel. This would become positive 4x cubed since you're subtracting a negative, and this would be negative 2x squared, since 6 minus 8 is negative 2. So be careful, careful, careful. Show all your work when you're doing these so that if you make a mistake somewhere, I can follow and give you partial credit. Now we're looking at how can we get 2x squared to look like 4x cubed. You need to multiply by 2 to get 2 to 4, and then multiply by x to get x squared to x cubed. Distribute through to everything again. So we get 4x to the third minus 2x squared plus 4x. And then I need to drop this down so I have something to subtract from. So at this point, this one cancels like we wanted. Conveniently, this one also cancels because we're subtracting the same thing. And then negative 3 minus 4x is going to give you negative 7x. I'm going to bring this down. And at this point, I want to figure out, is there any way to get 2x squared to look like negative 7x? Nope, because we're 1 degree less than what we were dividing by. We're at an x now instead of an x squared. You can't make an x squared look like an x without dividing. So this is our remainder. So you get plus negative 7x plus 1 over 2x squared minus x plus 2. So kind of long and complicated, but it works. You just have to be super careful about your algebra that you're not like mixing up a minus or a plus. Otherwise you can get off really easily and then it messes up the rest of the problem. So an easier way is synthetic division. So this is a faster way of dividing polynomials, but it only works in certain situations. So it only works when you're dividing by something that's x minus c. So this could be like x minus 2, it could be x plus 2, it could be x minus 4, but it has to be just an x and some other number. As a note, you could do like 2x plus 1, because you could rewrite this as x plus a half and then divide by a half. So you need to just be dividing by some sort of x instead of like an x squared or an x cubed. You've seen this before, so here is a note if you want an explanation of why it works. Look at page 200 of your textbook. We're just refreshing how to do it. So here is a long division problem. We had this 2x cubed plus 2x squared minus 45x plus 20. We want to divide by x minus 4. You can see the whole process there. But this is an x minus c form, so we can do synthetic division. The c here is going to be 4, so it's always opposite what it is. So if you have x minus 4, your c is 4. If you have x plus 4, your c is negative 4. Because the formula is x minus c, you want the opposite. What you do then is you take this 4 and put it in a little box, and then you take each of the coefficients, so the 2, the negative 45, and the 20, and write them in a row at the top like this. You have to have a placeholder for every single spot. So you need to have an x cubed coefficient, an x squared coefficient, an x coefficient, a constant coefficient. You can't like miss something or it will mess up the whole process. So if you don't have like an x cubed term, you need to put in a 0. Now how to actually do this. You start by dropping down the first number. So don't do anything with that. Now you're going to do 4 times this number and put it under the other 2. So 4 times 2 is 8. I'll put that right there. And then you're adding these columns together. So you get 10. Now do 10 times 4. to get the next one, which is 40. Add those two together, and you get negative 5. And then do 4 times negative 5 to get negative 20. Drop that down. And then this last number I always put in another box. This is always your remainder. You write this 0. So then how you get your answer is you want to kind of work backwards. So this is your constant term. This would be the x term. This would be the x squared term. And then you can write that out. So we'd get 2x squared plus x minus 5. And then the remainder is 0, so we don't need to do anything with that. And that's your answer. And it should match what you have up here. Oh, this should be 10. Bring your coefficients down with it. Okay, so try this one on your own, and then I'll talk through it. So if we write this out, our c is negative 2. So you have negative 2 in your box. Take the coefficients. So you have 3, 5, negative 4, 7, and 9. And set up like this. And then double check here we have to the fourth, to the third, to the second, to the first, and then nothing. So we don't need any like placeholders in this one. Drop down the 3. Then do 3 times negative 2 is negative 6. Add those two together, and you get negative 1, which will then give you 2, gives you negative 2, which gives you positive 4, which gives you positive 11, negative 22, negative 13. So you get pretty fast at doing this if you do it more than once. Again, this is the remainder. So if we write this out, this is your constant term, this is your x squared, your x to the third term. So we get 3x to the third. Grab a drink of water. X to the third minus x squared minus 2x plus 11. And then the remainder at the end will be plus 13 over what we divided by, so x plus 2. And that is your final answer. Okay. So here is another one. This one we'll be a little bit more careful with. So c is 2. And then we have 4. But then here, if we look at this, be careful with the setup. We don't have an x to the third term or an x squared term, so we need to add some zeros in. So we have 0x cubed, 0x squared, and then we have the negative 10 and the negative 2. So make sure you're including those, otherwise it messes up your answer at the end. So again, we drop down the 4, multiply to get 8, add those together, multiply to get 16, add those together, multiply to get 32, add those together, multiply to get 44, add them together, and you get 42. Now we can write this out. We'd have 4x to the third plus 8x squared plus 16x plus 22 plus 42 over x minus 2. And that's the answer. So a side note here, if we plug in 2 to our function, we want to see what we get. So if you plug that in, you do 4 times 2 to the fourth minus 10 times 2 minus 2, and you'll get 42. So you want to think about, do you notice anything? You should be noticing that these two numbers are the same. So that brings us to the remainder theorem. So polynomial p of x is divided by x minus c. Then the remainder is equal to plugging in that c to your function. So if you get a remainder of 2, if you do p of 2, or p of whatever your c value is, you should get 2. So you can just plug in that number to figure out what the remainder is instead of actually dividing. So some examples. We want to find the remainder of this when we divide by this. So just plug in 2. And this one will give you 21. Same idea for the next one. Plug in 1. So 1 to the 30 plus 2 is 3. And if we plug in -1 for this one, you'll get 9. And that's an easy way to find the remainder. So that's it for today. Go on to Schoology and look up your homework.